This will definitely be on the AP Calculus exam. There's the sandwich theorem, the intermediate value theorem, and the fundamental theorem of calculus, and there's two parts to that. You need, though, if you have to memorize 4 theorems, those are the ones. Okay? So this is one of them. Functions that are continuous on intervals have properties that make them particularly useful in mathematics and its applications. One of these is the intermediate value property. A function is said to have an intermediate value property if it never takes on 2 values without taking on the values in between. And so we have the example here, and I'll read the formal definition, then we'll talk about it a little informally. A function y equals f of x that is continuous on a closed interval from a to b. Okay? And it takes on every value between f of a and f of b. In other words, if y naught is between f of a and f of b, then y naught equals f of c for some c in a and b. Now, that's the formal language. On the test, it will be written formally. Right now, it's probably very confusing to you guys because you're not used to a lot of formal language. But what is it saying? It's saying that a to b is an interval. Those are x values. This is the x value a and the x value b. So we have an interval of x values that go from a to b. Then they're saying that the function takes on every value between f of a and f of b. F of a and f of b are fancy ways of saying y sub 1 and y sub 2. 2 different y values that correspond to these x values. So here's a, which is an x value, which is a number. We plug that into our function, and it spits out a y value, which we call f of a. So this point right here is a comma f of a. Here is b, that's a value we plug into our function y equals f of x, and it spits out a corresponding y value of f of b. This point right here is b comma f of b. Now what they're saying is if the function is continuous, then there should be some value in between them. In other words, there's some x value that lives in between a and b that has a corresponding y value. That's all that's saying. And where does it live? Well, if c is between a and b, then the corresponding y value, f of c, should be between f of a and f of b. Now, we'll talk a little bit about how you could determine what these functions are, but the first thing is it has to be continuous. If it's not continuous between a and b, clearly you could see where you might run into issues. By it not being continuous, that means that there's a gap. And so if there's a gap and I pick c and it's gonna have a gap, or it's not continuous at c, then I'm not going to have a corresponding y value. And the y values are the things that we're interested in because that's what we use to make predictions. Remember that x is the independent variable and the value for y depends on whatever x is. So this is very formal, but it makes kind of sense, right? As long as there's no, like, think of this like a jump rope or something, right? If I break the jump rope, then it's no longer one jump rope. It's 2. And then it's not as consistent, right? So as long as the function is continuous, then there should be a point on that curve in between the two. But if it were a jump rope, I would say that the rope is one long rope and there should be a point in the middle of the rope. But if the rope is broken into 2 separate ropes, discontinuous, then I can't necessarily say that there is a point that exists in the one rope because technically it's 2 separate ropes. Does that make sense? That's what we're saying. So certain functions, clearly there are a lot of functions that we could use this intermediate value theorem. Now the reason to get kind of fast forward a little bit, sometimes it gets messy as you get closer to c. So we use this intermediate value theorem for lots of applications, but really what it boils down to is we could do some work at A And we could do some work at B, but it gets messy at C. So if I make A and B get really close to C, then f of A and f of B, they get really, really close to f of C. And that's where that's helpful to us in some situations. But we can only do that if we prove that f of x is continuous from A to B. Does that make sense? Am I over talking it, or you guys got it? Are there any questions?
Got it.
Got it. Okay, good.